Hello, welcome to the Mr. Marsh Show. You need pencil, paper, calculator because the tool of your mind is the pencil, and we think best when we write down. So get some pencil, paper, calculator. I have a song that goes pencil, paper, calculator, but you can learn to sing it later. Let me share my screen with you. So I think we're going to do some geometry, which actually I'm teaching this year. Haven't taught geometry in a while. I kind of like it. But anyway, you should have something that looks like this, right? All right. So you got some silly pictures. What's that? Doesn't look like a giraffe. Doesn't look like a football. Not like anything you ever drew with, connect the dots or something like that when you're in first grade. So let me see if I can talk you through this one, and I think if you get the idea, you'll be able to apply it to the other ones. So number 9. So we got this figure here, and remember that the area is the space inside. And so area, if I'm going to do it, area means like all of this. Like if you were to paint it, how much paint would it take to fill that whole thing? All right. Now, perimeter is something different. Perimeter is what you get if you go around the outside. So perimeter is the distance around. I forgot an N. I'm sorry, I have to fix my spelling. I'm trying to rush, and when you go fast, you make mistakes. So it's better just to be smooth, because smooth is fast. Distance around the outside. So maybe this is some strange courtyard or something like that, like, I don't know, a sport field. What kind of sport plays? I don't know, something like this. Frisbee golf, or I don't know, something strange. And if you picked a spot, and if you walked all the way around the outside, how far would you walk? That's perimeter. And notice this shape, I think the main idea for this kind of question is you don't have a common shape. What you do is you've got a bunch of smaller little shapes that are put together, parts or holes or something like that, or sometimes subtractions. And so this is called like a composite diagram. So let me just show you what I got real quick so you can maybe get the idea around your head. I see a half of a circle right here. There's the full circle. And what we have is we have half of it. I also see maybe a triangle right here. There's a triangle right there. I also see a rectangle. Now maybe you see a big rectangle right here, which maybe you do. Or you might see like a smaller little rectangle right here. The problem is going to be, I think, with this spot down here in the bottom. Like if I draw it like that, then there's a rectangle, and in green, this is a trapezoid. Maybe you know about a trapezoid. I'm hoping maybe so. If you do the big rectangle, though, we don't want all of it. So we could do something where you take this space right here and you subtract it out. Sometimes that's the easier thing to do, is to take a hole and then remove part of it rather than putting together a bunch of smaller parts. But looking at the diagram, I'm not sure that that's the best way to do it. It seems to me like I would like the trapezoid thing better. So let me just review a couple formulas for you. You should know these. If not, maybe you're learning them for the first time. Who knows? We got the area of a circle. The area of a circle, we did that one first. Area of a circle is going to be pi times r squared. Maybe you know pi is 3.14. Area of a rectangle was going to be width times length. You might have done length times width, but I always do the width first because of algebra reasons, but it won't matter here. A triangle, area of a triangle is equal to 1/2 base times height. But the better way often to think about it is the base times the height, then divide by 2. Same thing. Just makes it a little easier than multiplying by a half. You just find that and then divide by 2. And then I don't know about that last one there. This little trapezoid right here, this is kind of a complicated one, although it's not that bad. Area of a trapezoid is going to be, oh, what is it? We got 2 bases. We have a base on top, a short one, and a base on the bottom. It's base 1 plus base 2, all divided by 2, so it's the average of those, and then times the height. Okay, so I'm not sure that you need to even use formulas so much. Let's just, my strategy for this, and I don't know the answer. You're like, when I figure this out here, I'm going to be working live. So I'm going to try to talk out loud, and you'll get maybe the benefits of just my thinking. I either need to find whatever the area is of this hole and subtract it off, or I need to find the area of this and add it on. I think it'd probably be a little easier to add it on, but this 3 feet thing is messing with me. It's not the top to bottom. It's the slant. Sorry, that's my clock. It's 1/4 the hour. What time is it where you are? It's time to finish the question. Okay, so I got 3 feet right there. I might be able to do like another little triangle in here, maybe. Like, I don't know. I'm not sure exactly how much geometry knowledge you've got. Like, anyway, let me just see if I can start to piece something together. One of the first things I'm going to do is I'm going to go through and label anything that I don't already know just from straight logic, and I can figure it out. If this whole top here is 13... and this bottom here is 10, then since it's a rectangle, I know it's a rectangle because we got these right angles here, and I'm assuming it's a right angle right there as well, then I know that this little spot right there to there, that's going to be, if that's 13 and that's 10, this has to be 3 because all together along the bottom it's got to be 13. So I'm just going to label some stuff in there. If this is 24 and this is 22, if I come across here like this, it makes this 2 and this on the inside also 22. I don't know, I'm thinking here. 23 feet is the diameter right there. So half of that would be, what, 20 or 11 and a half? A radius of the circle is 11.5. What's this distance down there along the bottom? Because if I did that, then I would have a triangle like right there. How do I know what that is? Now, the only way that I would really know that is if I actually knew the Pythagorean theorem. I don't know that you know the Pythagorean theorem or not. In fact, let me text somebody and see if you're supposed to know the Pythagorean theorem. Let me press pause. I don't know what key is pause. Here we go. I got a cursor. I'll pause the recording. Hang on, let me get an answer. There's no sense to draw this out live. So the word is yes. You're supposed to know the Pythagorean theorem. All right, so I'm going to find out this piece right here. So I have this right triangle. Oops, I'll do it in red. My first computation. I have this right triangle right here. And the hypotenuse is always across from the right angle. So the hypotenuse is 23. This is 22. I need to find this distance down here. I'll call this little thing A. Just that short distance right there. So, Pythagorean theorem. C squared is equal to A squared plus B squared. C has to be the hypotenuse, so 23 squared has to be equal to 22 squared. No, I'm sorry, I'm A here. A squared plus 22 squared. If I move 22 squared to the other side, A squared equals to, I'm going to pull out my calculator. It's going to be 23 squared, which is 23 times 23, minus 22 squared, which is 45. Oh, this is nasty. This is going to be 45. If I do my right, I'm going to double check one more time. 23 squared minus 22 squared equals, yeah, it's 45. So A, that length is the square root of 45. Are you allowed to use decimals or do they want whole numbers? Let me pause and ask that. Okay, the answer is round to the nearest tenth, which is 1 decimal place. So if I do the square root of 45, that's going to give me 6.7. So this little distance down there, A, I'm going to update now, is 6.7 feet long. So this is 6.7. So now, the only thing that I have left perimeter-wise is going to be this little section right here. How long is that little piece? I don't know. I'm going to pause the video and think about it a little bit. All right, I got a plan for this little crazy corner here. I'm going to redraw this arrangement down below. Keep in mind that this distance right over here is 2, so this distance here also is going to be 2, but I'm going to bring that down below. It's going to look like this. It's going to have a long part here. It's going to have a part like this, a part like this, right there. This is 3. This has to be 2. And this part down here has to be 3. And this part right up here in purple is the part that I don't know. So I've got this arrangement from right here. Okay, so I'm going to zoom in here now and take a peek. Okay, so what I need is, if I draw a rectangle right here, this piece is 2. The part that I don't know is that right there. But if I make this a right angle, like I said, then isn't this distance right there 2? So then I get this arrangement where this is another little a right here. So again, c squared is equal to a squared plus b squared. C in this case is 3, so it's 3 squared is equal to, I don't know squared, plus 2 squared. This is going to be 9 is equal to a squared plus 4. Maybe you can see that this makes it a squared is equal to 5, and if I square root 5, then for the answer, that's approximately, I get 2.2. So this little section right here, A, is equal to 2.2, which means the whole thing right now is 4.2. All right, so now I can go back up here, and I think I have enough to answer the perimeter. So that little distance right there is 4.2. And I think I got all the parts now. No, I don't. I got to do one more little part. I got to do this outer distance around the half circle. Another formula I'm going to add back in here. The circumference, which is the distance around a circle, is equal to 2 times pi times r, or you could say the circumference is equal to 2 times the diameter, because they give us the diameter. Remember, because the diameter is twice the radius. So what is that distance, that arc, that semicircle around there? That's half the circle. So if I take this value and I divide it by 2, I should get the answer. So what was that diameter, 23? So it's going to, whoops, I'm sorry, I gave you the wrong formula. It's late. I've had too much coffee as it is. It's going to be pi times the diameter. So I'm not very organized, but I'm going to come over here. This is a geometrical question about parts, and you're going to get my work all in parts. So the circumference is pi times 23. Was that the, yeah, 23. And so then if I take this and divide it by 2, then that should be my answer. So pi is about 3.14. I'm going to multiply that by 23 and then divide that by 2. And I'm going to get a value here of that distance around the semicircle, 3.14 times 23, and then divided by 2 equals 36.1. So 36.1 is my distance around that circle. I'll do it in hot pink so maybe my colors match up. 36.1. Now, so let me erase a little bit so that I can show you the final collection here. If I start and I walk all the way around, I'm going to do it in blue. If I walk all the way around, I'll start just here on the upper right corner because it's the most comfortable one. It's just nice and clean up there. It's going to be 13 feet, that's that distance, plus the 36.1, that's that distance, plus 6.7, that's that distance, then plus the 4.2, then plus the 3, then plus the 10. That's my alarm to go to bed. Or at least think about going to bed. And then I'll do the whole thing here, which wasn't 2. Remember, it's the 24. All right, so pause the video and add all those numbers up, and that should give you the perimeter. Did you get all that? I added them all up on my calculator. Surprise, surprise, surprise. I actually got straight up 97. What's the unit? Feet. Now, I'm working with decimals, so I didn't expect it to come out to be a whole number decimal. If you did the work, it's live video. It is what it is. You get everything here tonight. At least you don't get my bad breath because it's on video. I got 97 feet. So why don't you give that a try and see if you get the same thing, and then maybe we'll press hold. Maybe we'll stop this video and I'll just send it to you and we can work on the perimeter tonight. And then maybe another time if you check and see, hey, that actually worked out, we can then work on the area. I think the area might be actually a little bit easier. I try to do the complicated one first. Or if I made a mistake, let me know, because I'm prone to make math mistakes. But when you write your thoughts down with paper and pencil, you can actually look at your thoughts, good or bad, and rethink them later on and decide if you were telling the truth or telling lies. So I think the perimeter is 97 feet. So let's call it quits on that for right now, and maybe we'll do another video in a bit on area. All right. You got what it takes, but you got to write it down. I don't think they gave you enough workspace to write it down there. Like I did a whole bunch of work on paper. Pencil, paper, calculator, line paper is best. So anyway, off you go. See what you can do.